This is a 25-minute presentation for architects. Gamalux Lighting Systems is a family-owned manufacturer in the linear lighting systems business with headquarters in San Dimas, California. Our most popular product line is the GBeam, or the Gamalux Beam series of fixtures. And this is that group of square and rectangular forms that have been so popular in the business for the last 15 years or so. Now, what makes our product so popular is not its shape, because everybody has basically the same shapes and sizes in the lighting business, but rather than the product itself, what we try to do is focus on the project and create what we call total architectural integration. This is where we're actually becoming part of the space and lending the product to the overall design of that space in a creative and functional way. For instance, in this application here, you can see that the walls and the ceiling don't touch each other. And of course, this is very unusual because most walls and ceilings touch. But in this particular case, the architect wanted to convey the concept of the ceiling floating up and down on rails of light. Well, it doesn't really move, but that's the concept they wanted to create at the remodel for Schindler Elevator Corporation headquarters. So, understanding what the concepts were in the space, this is where we came up with the idea of modifying the fixtures. See, the reason for modifying the fixtures is because if we use a standard recessed product up inside the ceiling, which makes sense, the problem with that is that you would see the side of that recessed fixture as you walk down the corridor. And of course, nobody likes to see the side of a recessed fixture because it's not very attractive. It's got grooves and brackets and holes and things because they're not really meant to be seen. So what we did here, instead of using a recessed fixture, we took a suspended fixture with the smooth sides on it, very common style of product, and we modified that fixture only in the areas where the fixture was actually going to interface with the ceiling. But we did not modify the fixture in the area where it was going to be exposed inside that 3-inch gap between the wall and the ceiling. And so now, when this pattern of fixtures is installed, the portion of the fixture that's visible inside the 3-inch gap is the nice smooth side on the housing, rather than grooves and flanges and holes and brackets and things of that nature. And of course, when we build the fixtures, we want to be careful for something like this. So we recommend when you're specifying a pattern of fixtures, don't specify a fixture to be recessed in the wall and a fixture to be recessed into the ceiling, because this is something that you're going to end up with similar to this, where it's up to the contractor to try to figure out how everything goes together. What we do, instead of providing two distinctly different fixtures, we actually provide an L-shaped fixture that comes up the wall and comes across the ceiling about 6 inches or so. We make that as an L-shaped fixture, like a hockey stick, at the factory. And so we make that entire fixture out of that modified suspended fixture. And then about 6 inches away from the wall, that's where there's a nice, very simple butt joint that the installing contractor will work with in order to finish off the pattern of fixtures. So we're going to give the contractor the most simple form of installation possible while still maintaining the original design intent in the space, while also avoiding the problems of using a product that should not be visible on the sides of the fixture. So again, total architectural integration requires a lot of collaboration with us, the specifier, and of course the installing contractor as well. Now, when we're dealing with very complex patterns of fixtures, you can see here in the reflection in the glass, this is one pattern of fixtures weaving its way through the entire building, through the whole floor of that building. Now, if you think about this big complex pattern, obviously there are a lot of parts and pieces that are associated with it, but we don't want to leave the distributor or the contractor in the position of having to order and figure out all those parts and pieces. So what we do is we work closely with the designer and give them what we call a development drawing. This development drawing is provided before the job goes to bid. And what we do is we take all of the design concepts out from that pattern of fixtures and we place it into one drawing with one part number associated with the entire pattern of fixtures, so that when the distributors and contractors get a hold of that bid package and they request a quote from the local sales office, they're all asking the same question, so they'll all get the same answer. It creates consistency among the beds, or at least as far as the resources that we provide to them. Also, when we provide that development drawing, we can also provide the quotable price to the specifier through the sales office, of course, because they need to add the distributor and contractor markups, which we don't know here at Gamalux. But what we're doing here is we're providing clear and concise understanding of the patterns of fixtures, as well as a clear understanding of what the price should be to purchase those fixtures. So it eliminates a lot of the question marks associated with these very complex patterns of fixtures. Now, everything we build at Gamalux is actually fully assembled twice. First, before it's painted, to make sure all the joints line up properly, all the locking mechanisms work the way that they're supposed to, all the dimensions are correct. Then we take the entire pattern apart, paint it, put in the electrical, and reassemble the entire thing, checking all the circuits, all the battery packs, making sure that the housings are painted consistently from one housing to the next, so making sure that the lenses are fully illuminated. We're checking not just the performance characteristics, but also the aesthetic characteristics of these patterns of fixtures before we pack and ship them. So we're very thorough in our methods. Now, if you want to have fixtures embedded into the walls, usually you don't want to see that visible flange that goes around the fixtures, that visible framework, if you will. So you specify what you call a flangeless fixture. Well, the flangeless fixtures really do have a flange on them, but they're a mud flange. It gets mudded over and painted so you can't see it. And we have the same thing as well. But we have an element in our mud flange fixture that nobody else has, an expansion gap. See, we include an expansion gap of about a 32nd of an inch as part of the construction of our fixture to separate the housing from the mud flange. The reason for this is because when the lamps come on, they're going to create a little bit of heat, and this is going to heat up the housing in relation to the surrounding wall, and any material that heats up expands. So by having an expansion gap separating our housing from the mud flange, then whether the housing expands or even if the walls expand, the two won't be putting pressure on each other and creating cracks surrounding those fixtures. So this is why we operate the way that we do, why we use the kind of components that we do to ensure that the aesthetics are good for the duration of the lifespan of that building. Now, this is not a back box or something the installing contractor has to figure out on their own. This is our own construction, so it's not something that they've got to try to figure out how to put together. Now, here's an application in an architect's private home. This is his guest bathroom, where he's got this half-inch reveal all the way around his mirror. So the mirror's kind of floating in space. So let's zoom in here and see what the finer details. Now, normally speaking, we would put our mud flange around all four sides of our fixture if it was ordered with the mud flange. But the problem with that is you would see the mud flange in the gap between the fixture and the mirror, and obviously that's not something that you want. So now it would be the installing contractor's responsibility to pull that mud flange off the bottom of the fixture and then fill in the holes that he's created, and then try to find the right color of touch-up paint to fix the mess. And certainly that's something we want to avoid. So with proper collaboration with the designer, when we find out that there's supposed to be a half-inch gap between the mirror and the fixture, all we'll do is put our mud flange on the top and the sides of the fixture, but not the bottom. And by doing that, we modify the fixture appropriately for that particular job, and we do those modifications at no additional cost. Now, if we're building fixtures all the way around all four sides of the built environment, obviously we have to have exact field dimensions for that kind of thing. Now, we quote to CAD or designed dimensions, but we do not build to designed dimensions because we know the walls will not be built to designed dimensions. So once the stud framing is up, the contractor knows what the thickness of the gyp is going to be, and then they can extrapolate what that corner-to-quarter dimension will be, and that's the dimension that we need on our signature-approved shop drawings before we go into construction of these fixtures. Now, here's an application where we took a standard 4-inch wide, 4-inch tall direct illumination fixture. It's a linear fixture suspended on cables or maybe surface mounted on a ceiling. But rather than having it direct illumination, what we did is we built patterns using the very same fixture, only rather than having the installing contractor have to put together all these miter joints in the field, which would just be absolutely impossible. Again, we made them L-shaped fixtures with a butt joint away from the corner, or V-shaped fixtures, again, with the butt joint away from the corner. What we're doing is we're giving the installing contractor the most simple form of installation and joining possible so that we can maintain the original design intent for AVA medical facility in their parking garage to point people in the direction of where they need to park to go visit the company. Now, in addition to our standard white lens, we can also add polycarbonate lenses for vandal resistance into our fixtures, and we can hold those polycarbonate lenses in with tamper-resistant fasteners so that we're creating a bit more of a vandal-resistant type of fixture in an application like this. But again, this is not a custom fixture. This is a standard fixture that's been modified for the specific needs of the space. Now, all of our fixtures can be built for individuals or in patterns or in continuous runs. Now, obviously, they have to be ordered that way so that we can put the right components into the ends of the fixtures. But when you specify a run of fixtures for continuous run illumination, obviously we're going to let them be continuously and fully illuminated. There aren't any shadows in the middle where two different housings were joined together and there's a gap in the LEDs, or maybe even having shadows at the end. We don't do that kind of thing. We always fully illuminate our continuous runs of fixtures. To my knowledge, we are the only manufacturer left that can actually make one housing up to 24 feet long, all in one piece. Now, I say the reason the last manufacturer left to do this because a lot of manufacturers used to be available to do this kind of stuff. But as they get bought up by the conglomerates, very soon all their special characteristics and capabilities go away, and they just become another one of the herd. So Gamalux is a family-owned company, privately owned. We're not for sale, and so we still have all these great capabilities that help you to do creative things. Now, in a case like this where you're working with a very tall, like a tall rectangle, there's a lot of rigidity to that kind of a housing, so we can support that entire 24-foot housing with just 2 support cables. So you're cleaning up the ceiling system. Obviously, it's very aesthetically pleasing. You're eliminating any gaps or light leak because there is no multiple housings being joined to create gaps and light leaks. You don't have the potential for pinching wires between the housings. It's easier for the installing contractor to install. It's easier for the distributor to order, and it's aesthetically pleasing as well. Now here's an application where we took a 12-foot long suspended fixture on cables and we just modified the bottom of that 12-foot fixture to allow it to interface with the ceiling for 8 feet of that 12-foot housing. We added mounting brackets that we coordinated with the installing contractor before we started building fixtures so that when he opens up the boxes, he knows exactly what he's going to be working with. Now, because this is one extruded aluminum housing, very rigid material, we're actually cantilevering out of the wall 4 feet with no cable support from above. Very nice, very nice. Now, this is not a custom fixture. This is a standard product, simply modified. This went out to the job site at less than $200 per linear foot. So there's a lot of value in doing this kind of stuff. Now, here's a residential application very similar to the previous shot. Remember that architect with the bathroom mirror? Well, this is his kitchen. He's got an 8-foot countertop, and he's got the fixtures centered directly above the countertops. So he has 3 feet in the ceiling and 5 feet sticking out. That's why we need the support cable. But if it's the other way around, where the majority of the fixture is recessed in the ceiling and only a few feet sticking out, we don't need the support cable. So it just depends on what's going on in the space. We'll determine whether or not we need the support. Now, here's a recessed pattern of fixtures, a square pattern of fixtures in the ceiling. There's a wall right here, and so we're looking straight up to the ceiling above us. Now, this ceiling is gyp and also grid. So what we're doing is we're using the pattern of fixtures to delineate and differentiate those 2 different ceiling systems. We have our mud flange running around the outside of that pattern of fixtures to interface with the gyp ceiling, and then we have a different flange on the inside of that pattern of fixtures in order to interface with the grid ceiling. And the architect on this job wanted the grid ceiling to be raised up 2 inches above the bottom of the fixture. So that's very simple for us to do. We can raise our flanges and put them at whatever level you need above the bottom of the fixtures to create a semi-recessed effect, even though the fixtures are flush with the gyp on the outside of that pattern of fixtures. We can make wayfinding applications as well, where we're coming up the wall, across the ceiling, and then shooting down the corridor. Also at any angle. You saw that AVA pattern where we're doing multiple different kinds of angles, not just 90 degrees and 45. So we're not bound to just those two dimensions, those 2 angles. Now here's an application where we took our fixtures and actually created steps in the ceiling, coming up to the center and then back down to the other side. And if you think about a step ceiling, there's a lot of complexity probably involved in stuff like that. Certainly a lot of hands in the cookie jar because everybody thinks that they're going to make a lot of money on this custom application, and that's just not. It doesn't have to be that way. See, what we did here is we found out what the ceiling system was. This is the Armstrong Axiom ceiling system, which uses an extruded aluminum C-shaped channel that gets installed up against the walls at the ceiling line. And then the grid snaps into that C-shaped channel and slides along that channel until it's in the right position, and then they drop in the tiles. So what we did is we got a hold of that C-shaped channel called the vector trim, and we attached that vector trim to the sides of our fixture at the factory. Of course, everything was cut to the same length and painted with the same paint, so it all looks like one comprehensively designed unit. Now, when the fixtures arrive on site, the installing contractor supports those fixtures and suspends them at the right locations, at the right height, and then the ceiling contractor gets in and just snaps the grid right into the sides of the fixture. The grid is supported independently, the fixtures are supported independently, but they're all interfacing with each other in order to create a beautiful installation without any of the custom dollars associated with a custom step ceiling. Now, in this application here, we've got a single piece 18-foot housing, all one piece, going from fully recessed with flanges down low to carry the cut tiles, and then semi-recessed with flanges up high to carry the cut tiles. Rather than working with a recessed fixture with the grooves and brackets and holes on the side, we're working with a smooth-sided suspended fixture that we've modified so that it can be recessed. Now, the architect on this job wanted this trim to butt right up against the side of our fixture, but you notice that actually that trim approaches our fixture at an angle. This means that the trim is touching the fixture at slightly different locations on each side of the fixture, but because it's happening at an angle, it also occurs at a different location in every single fixture, all the way down this side of the room, all the way down the left side of the room on 6 floors. This is all one type on the fixture schedule, but no two fixtures were identical. We cut our flanges at just the right locations, sometimes a little bit shorter, sometimes a little bit longer, both on the upper portion and the lower portion of the fixture, to allow this trim piece to butt right up against the side of our fixture in between our flanges so everything fits together like puzzle pieces. We are very much into the fine details. We cut our trims on this job down to 256 of an inch to ensure that everything fits properly. Now, here's the Hunter Douglas textile ceiling where the panels snap onto the grid from below, and the panels are 1 1/8 inch thick. So what we did is we modified our fixture so it could drop 1 1/8 inch below the bottom of the grid. And now the fixture is flush with the bottom of the adjacent ceiling panels. Also, we flared out the bottom of our fixture so that it actually underlaps the grid just like the panels do. See, there's a grid up here, but you can't see it because the panels are underlapping the grid at all the joints. So by flaring out the bottom of the fixture, we maintain that nice 1/4 inch gap that all the panels have between them. By doing this, we have a totally architecturally integrated lighting system in this very special ceiling system. Now here's the Armstrong Tech Zone ceiling, the 6-inch zone and the 4-inch zone, which is what is shown here. Now normally, most manufacturers are not able to make a continuous run in the 4-inch zone because of the presence of the U-shaped yoke that holds the grid members in the proper alignment. We don't need the yoke because we're using extruded aluminum housings, which are very rigid, and we have brackets on the side of our fixture that hold the grid nice and straight up against the side of our extruded aluminum housing. So by doing this, we're able to create continuous runs in the Armstrong Tech Zone 4-inch zone ceiling without the presence of the U-shaped yoke. This is the Hunter Douglas Box Series metal ceiling system where they have nominal 4-inch and 6-inch panels. We've made our fixture the same width as the panels. And we have a joiner spline in line with our fixtures so it interfaces with the cut panel at the ends of our fixtures. So the fixture itself becomes part of that ceiling system in a fully integrated way. We actually use the same brackets on the top of the fixture that the panels require so that everything fits together in a kind of a cohesive and complete way. Obviously, you want to avoid this kind of thing, these one-size-fits-all solutions that don't really work out, because the truth is one size only fits one, and the rest are compromises. Gamalux wants to understand, we want to know what kind of ceiling system you're using and even what kind of grid you're using so that we can build our fixture to the proper dimensions to avoid this kind of aesthetic problem. Now, we offer fixtures of multiple widths, and if you'd like to use fixtures of different widths on the job site, you're also going to get different apparent brightnesses. So what we can do is offer to custom program the drivers in all the fixtures to equal them out so you get the same apparent brightness throughout the entire job. And we will custom program our drivers either for a certain level of output that you want or for wattage restrictions that you have to comply with. And we do those custom programming at no additional cost. We will also make our fixtures suitable for damp location if you require that. This is an outside area where there's a lot of moist air coming in up in Seattle. A lot of moisture, and of course it accumulates inside the housings and turns to condensation. So we don't want that to be a problem. So we finish off the components inside the fixture a little bit differently for these damp location environments. So we can make all of our fixtures suitable for damp location, but we do not offer wet location or natatorium or indoor pool type of fixtures because the chemicals will just eat right through the housings, the drivers, the LEDs and such. So those are really the only two things we don't do, wet location and natatoriums. Now, wall washing is a very important part of good design. Obviously, if you have an object wall, you want to illuminate that properly. So we have a kick reflector on the bottom of our wall wash fixture that actually illuminates all the way to the top of the wall to eliminate that shadow that most of our competitor products have. Also, that kick reflector acts as a glare shield so the people inside the room can't look into the fixture itself. You have to actually be below the fixture in order to see into it. We can make our fixtures in any length necessary so that you can get consistent construction from one side of the room to the next. Now, all of our fixtures can be built as individuals or continuous runs, and we can even do fully illuminated corners with this product. In the world of perimeter lighting systems, there are a lot of things that are wrong with some of our competitor products. One of them is that there's a gap between the back of the fixture and the wall, because the wall is never straight, but the fixture is. So the manufacturer of these products doesn't want to put their fixture directly up against the wall. Now, they do that by setting the fixture off the wall intentionally by using some kind of a bracket system. And we don't think that gap looks very good, and most designers don't as well. So what we've done is developed what we call a mud flange for the perimeter series. Now, this mud flange gets mudded over, and you can see that it's attached to the face of the wall just above the ceiling line right here, a couple inches above. Now that mud flange has a groove in it ready to receive the reflector assembly from our fixture. Now what this does is it eliminates that gap that's often, all too often, visible between the back of the fixture and the wall. We have two types of illumination. We offer grazing illumination and ambient illumination for two different purposes. Grazing illumination, of course, shoots light straight down the wall, so you get shadows on even the most shallow of texture in the space. But be very careful. Do not use our grazing illumination fixture on a flat wall unless you know that it's a level 5 finish. Obviously, if there's texture on the wall, you're going to create all those beautiful shadows on that texture, the brick, the stone, and such. But if you've got a flat wall, but you don't think that's going to be perfectly flat, do not use our grazing optic because you are going to highlight every dimple and pimple on that wall. Instead, what you want to use is our ambient illumination fixture that actually uses the wall as a reflective surface to bounce light back out into the space rather than shooting light straight down the wall. Now, we've also reintroduced the round fixture back into the world of lighting. It was gone for about 15 years or so because everything turned to squares and rectangles. But styles change, and certainly geometric shapes like circles, they're never going to go away. So we've reintroduced our round fixture. We've given it rotation capability so it could be aimed wherever you like in the field. Also, each independent section can be separately rotated from the others. So you can have some facing left, some facing right. They're fully rotatable 362 degrees, so you can aim them pretty much wherever you like in the field. Now, our GBeam Portal fixture uses the same GBeam housing that I've been talking about, which has all this great integration capability into the architecture. But rather than having that standard white lens on the bottom of the fixture, we've replaced that with a backlit acrylic, which is a very bold type of design. Now, we're not the first manufacturer to come into the market. This product here was the first in the market, but it has some problems, some aesthetic issues with exposed fasteners and fasteners visible through the clear acrylic. So we've cleaned all of that up because the truth is, if you're not going to be the first one to the market, you have to definitely improve on the previous designs, and we believe we've done that. This fixture can be used as individuals for a very dynamic type of installation or in continuous runs. Now, when you're using this product in continuous runs, there will be a small gap between the acrylic blocks, but that gap is consistent throughout, so it's not really an eyesore. We can install these fixtures in grid, in gyp, any kind of grid, wood ceilings, metal ceilings. We can even integrate into furniture systems. So a lot of capabilities for mounting these products. All of our LED fixtures offer RGB function on DMX control, and if you want white, we would allow that we would build that in a separate circuit so that you have capability of full output white rather than that dim kind of RGBW kind of white. Also, the acrylic blocks can be laser etched, so you can create signage for your client even if they don't have a signage budget. And this one element can be built into a complex pattern of fixtures using the standard lens, so you only use this particular element exactly where you want to draw attention to it in the space. We have 13 standard finishes in all of our fixtures, and we also offer wood grain finishes in all of our fixtures as well. There's a bit of an adder associated with that, and you're only going to use it sparingly, only in the places where you really need this kind of aesthetic. Thank you so much for your time. We hope you see that our goal is to become part of the architecture and give you the ability to do very dynamic and interesting designs. Thank you very much.